So, in the continuing series of lecture on the reinforcement detailing that I am covering, I am going to cover the reinforcement detailing of the junction in the RC frames. Now, the junctions in the RC frame structure are the places where the different elements meet. It can be a beam to beam or a beam to column type of junction. The beam column junction is the crucial zone in the RC moment resisting frames because it is subjected to large forces during the severe ground shaking during earthquake motion, and its behavior has significant influence on response of the whole structure. In Indian practice, the junction is neglected for any specific design and restricted to only providing sufficient anchorage by means of the detailing. Now, we can understand the unsafe design and detailing of the junction would jeopardize the entire structure if not done properly. The functional requirement of the junction is to enable the adjoining members to develop and sustain their ultimate capacity as per the design calculations. Hence, we can see the junction should have adequate strength and stiffness to resist the internal forces produced by the framing member more than the individual members. So, accordingly, we will see the various aspects of detailing of junction in this lecture. Now, coming to the detailing of junction, we can see the type of junction first. We can see on the right side it is a column and a beam is meeting, and in this case the dimension or the width of the column is same as the width of the beam. So, in this case what we have to follow? We will see the plan. So, this is the plan, this we can see this is the column, and now this is the beam continuing like this. So, in this case we have to ensure that the column ties is continued at the junction. It is not the beam ties, but it is the column ties that needs to be continued at this junction. We will take a section 1 like this and we will have the view like this. You can see, so this is the column reinforcements which are continuing in the same alignment from bottom to top, and this is the beam that is shown on the dotted lines. So, here we have to ensure this column ties whatever is provided on the column that should get continued inside this junction portion. This we need to ensure. Again, by taking a view in the section longitudinally 2 we can see over here. So, now this is the beam coming, these are the stirrups, there is no need to continue this stirrup inside the junction, but at the same time we need to ensure that whatever the ties that should be continued inside the junction and taken to the top story. And now, coming to the second scenario, here we can see the width of the beam is less than the width of the column. That means, the beam is of smaller size than the column. In this case, what again you have to do? Now, come to the plan figure. So, this is the plan, this the beam is now going and this is the column. We have to ensure that whatever the reinforcing bars of the beams are coming, that are taken inside the column cage of reinforcement. It should not be the beams bars should not be allowed to take outside the column cage. Generally, the people on the ground, the bar binder, they never follow that one because it is a difficult aspect for them. They generally take out this bar, the beam bar outside the column. That defeats the purpose. We have to ensure that whatever the column bars are coming, those are taken inside this column cage. Again, what we have to ensure that the column ties are continued at this junction. So, taking a section at 1 we can see over here, this is the column reinforcement that is going on. All the beam bars, those are taken inside the column cage, and again we are continuing this providing of these ties inside the junction itself. Now, getting a view, familiar view of the section 2 here we can see now how we are continuing these column ties over the junction. We are not continuing these beam ties over here. So, this aspect needs to be kept in mind and to be ensured on ground. Now, again coming to another aspect where the beam dimension is of larger than the column dimension. So, here we can see the width of the beam is larger than the width of the column. So, here what you have to ensure, again coming to the plan, we can see the plan. So, this is the column and this beam is going outside. So, here the beam reinforcement has to be taken outside because the beam is of larger dimension. So, when it comes here at a section 1 we can see now these are the column reinforcement and these are the beam reinforcement which has to be taken outside. But at the same time we have to ensure here we do not have to continue the column ties, but the beam stirrup needs to be continued at this junction. So, here by taking a a view of section 2 here coming, we can see that we are not continuing the column ties inside this junction, but we are continuing the beam stirrup inside the junction. So, this aspect has to be kept in mind what type of junction we are having, and accordingly we have to follow the detailing. Another scenario where the beam size is less than the column size and the beam is also getting flush to one edge of the column as shown in this figure. So, here we can see the plan. Now, this is the beam, now this is getting flush at one end. Again we have to ensure that the main reinforcing bar of this beam is taken inside the column cage like this. It is never allowed to be taken on the outside of this column cage. Again we have to ensure the beam stirrup in this case are also continued at this junction. So, taking a sectional view of 1 we come here, we can see. So, this is the beam, this is the column going as usual. The stirrup can be continued because the column is of the larger size. At the same time, we have to ensure the beam stirrups are also continued, like this one we can see this is the beam stirrup coming here. At the same time, it is feasible to provide the column stirrup, that is very much okay because column is of the larger size. Now, coming to the detailing aspect at the opening and closing type of corners. Let us first understand what is opening type of corner and the closing type of corners. This is the case where one wall is there, another wall is there. This basically we can take a scenario like the water tank. In a water tank, what happens, the pressure is given on this side as well as this side. So, out of this pressure what happens, the joint generally moves in this direction, that means the joint is opening up. But at cases where the pressure, suppose take the second case here where the earth pressure is there, suppose this side and this side, this joint is not opening up, but this is the joint is closing out like this one. So, in this case what you have to do, the ISP 34 provides the reinforcement detailing for opening corners, whereas for the closed corner it is not that critical one and basic detailing we can follow. But for the opening type of corners, what the reinforcement need to do is not be taking this reinforcement all along like this and all along like this. What we should be better doing, that whatever the reinforcement is coming, that is continued, given a loop and again continued in this portion of the slab or the wall. Again an additional bar can be provided in this distance like this to take care of this ridge portion, and whatever bars are coming from to that wall section, that should be given a bend or the crank and just taken like this. So, this ensures a very rigid joint at this location, which will prevent the cracking or the opening of the cracks under the loading condition. So, in case of closed corner, the basic detailing we can follow like this, one bar that is coming taken like this, given an anchorage point, and this bar is also given anchorage like this. So, this will suffice the need of the closing joint. I have taken the references of IS 456, SP 34 and some other material available. If you need to go understand what is the type of junction, the reinforcement to be carried out in the junction or the type of construction joint, we should follow SP 34 and other material that is available openly in the internet. So, with this I conclude. I thank you for viewing my lecture.